Alright guys, today we're going to be doing section 5.5 in your book. Basically what this section deals with is the arc functions, and the arc functions are useful in that they'll help you find angles instead of missing sides. So the arc functions look like this. If the sine of theta was equal to some value, let's say y, then the arc sine of theta, the arc sine of y would be equal to theta. So it returns the value that you entered in originally. Sometimes you'll see the arc sine written like this, where it actually says arc sine of something, or you might see this inverse sine or the arc sine. Either way, these two things mean the same thing. Let's try an example so you can see exactly what I'm talking about. Let's say that the sine of x was equal to root 3 over 2. You could use your unit circle to figure this out, or you could type it into your calculator and use the arc sine. So what I could do here is I could say the arc sine of root 3 over 2 is equal to x. So x is equal to, I could type that into my calculator. Arc sine is going to be right above the sine button on your calculator. You'll have to press shift or second. And then I'm going to enter root 3 over 2. And you can see that my calculator is returning the value 60. If you were to look on the unit circle, though, you would see that the value root 3 over 2 isn't only in the first quadrant. It could be that my angle is root 3 over 2, or sorry, the value is root 3 over 2, or it could be that 180 degrees over this way, the value is negative root 3 over negative 2. Those negatives would cancel out and give me root 3 over 2. So whenever you use the arc functions, you can't be sure exactly what angle you were given. It only narrows it down to a possibility of angles. So this could be 60, or it could be 180 more than that, which is 240. Okay? Usually that's what's going to happen. You're going to use the arc sine function or the arc cosine or arc tangent. You'll get a value in your calculator, and you'll need to remember that it could be that value, or it could be something 180 degrees more than that value. Usually the book will tell you what quadrant the angle should be in, and that'll help you narrow it down to one of those two choices. Let's try another example. Let's say that I'm told that the tangent of x is equal to 1. So I could say that the arc tangent of 1 is equal to x. And I can type that into my calculator to figure out what the value of x is. The arc tangent of 1. And my calculator returns the value 45 degrees. Again, on the unit circle, places where sine and cosine are equal to each other is where tangent will be equal to 1, because remember that tangent is equal to the sine over cosine. That's going to happen at 45 degrees here, where it's both have the value root 2 over 2, but again 180 degrees later they both have the value negative root 2 over 2, So it could have been this angle as well. So it's either 45 degrees or 180 degrees more than that, which is 225. You can verify that. We could take the tangent of 225, and you'll see the calculator also says that's equal to 1. So it's one of those two angles. Without further information, we can't really narrow it down. Let's look at another example. This is example 2 in your book. And this is a little bit more complicated. It says the cosine of the arc sine of 2/3. Okay, so in this situation, we're going to need to figure out what the arc sine of 2/3 is, and then we can find the sine of 2/3. So this theta that we're looking for, the thing that we're entering into cosine, is equal to the arc sine of 2/3, which means the sine of theta is equal to 2/3. I can build a triangle out of this if I remember the relationship for sine from SOHCAHTOA. If this is my angle theta, then sine is the opposite over the hypotenuse. So that's my triangle. I can use Pythagorean's theorem to find the missing side. So this is 3 squared equals 2 squared plus the adjacent squared. I can solve for the adjacent. It's equal to the square root of 3 squared minus 2 squared. And that's 9 minus 4, so that's the square root of 5. So the missing side of that triangle is actually the square root of 5. So if I'm trying to find the cosine of theta, remember that the cosine of theta is equal to the adjacent over the hypotenuse. So then I can just write in the square root of 5 over 3. Okay, so that's the answer. Let's try another example. This is example 3 in your book. In this case, we have the sides of the triangle and we're trying to find the missing angle. So let's say this is 17 and this is 32. In this case, we have the adjacent and the hypotenuse, so that's cosine. The cosine of theta is equal to the adjacent over the hypotenuse. So the cosine of theta is equal to 17 over 32. And that means that theta is equal to the arc cosine of 17 over 32. And you can use your calculator to figure that out. Let's see, the arc cosine of 17 divided by 32. And that gives us about 58 degrees. Alright, those are each an example of the types of problems that you'll have on the homework tonight, which is on page 309, and it's problems 15 through 33 odd. If you have questions about the homework, come and see me after school in the lower school science lab.